Olá, muitas gracias. Estou muito feliz de estar aqui mais uma vez. Espero volver outras vezes. Me siento muy bienvenido aqui. Muchas gracias a todos. And that was it, okay? In fact, I speak Portuguese, but, well, it's different from Spanish. But I hope that I got it right. And today, well, I'm Edson Yanaga. I'm a Director of Developer Experience at Red Hat, and I talk a lot about DevOps, microservices, Java, domain-driven design. And just in case you want to follow me, I share a lot about these subjects on my Twitter handle, @Yanaga. And today, I'm going to talk about many different deployment scenarios, from the most basic ones like blue-green, from rolling upgrades, A/B testing, canaries, using Kubernetes and OpenShift for achieving these results. So that's, we'll cover from the very basics and start from go to the more advanced deployment scenarios. So I hope it's helpful for you to be able to deploy software faster and especially more safely with each one of the solutions that I'll provide you. And I'm also a Java champion and a Microsoft MVP, and I work for Red Hat. How cool is that? That's it's just to check that the world has really changed. And for me, I have always been an open source advocate. So in the end, I really truly believe that even when the largest proprietary software company in the world joins the open source movement, it means that we have been doing something right in the past, like 15, 20 years. And that's why I'm so happy to be seeing all of these open source things and why are we developing open source these days. And I would like to give you a tip. I've just released a book from O'Reilly, Migrating to Microservice Databases, because I've been, last year I was here talking about a bit about microservices, but last year here too, the number one question that arises here was, but if the best practice is to get my huge, big, old legacy monolith and to split that thing into microservices, I still have an old relational big database. How do I deal with that? And I didn't have an answer last year. That's why I decided to do some research, and I travel a lot and talk with many different teams worldwide and try to gather some experience of how they solved this problem. And I've written a book writing this, with these experiences. And if you want to, Red Hat developers bought the royalties for the book. So if you check this URL, you can get the ebook available for free. I hope to have some copies, but I requested from O'Reilly, and I didn't know that they take like 2 months to produce the books, and more 2 months to get to Brazil. So we're in the middle of the equation. So I wasn't able to bring some hard copies, but I hope that if I ever have the opportunity to meet you again in the next conferences, I hope to have some hard copies. I think we still have a bug in the developers.redhat.com website. If you go to the landing page, we don't have a direct link to download the book. But if you go to my Twitter handle, @Yanaga, I've pinned a tweet with the link to the ebook so you can get the book to read that. So I hope you can enjoy the content, because I also hope that it's helping many different teams worldwide to know how they can split and integrate the data from relational databases to microservice architecture, which can be, why not, also using some relational databases. So the book's not tied specifically to relational databases. We have some very broad concepts, but well, it can be useful. And I always like to start my sessions with this sentence, which is not from me, but from Forbes. Now, every company is a software company. You don't work for a bank, you work for a software company. You don't work for an industry, you work for a software company, because software is changing the world that we live, and some people called it this new digital economy. And I'm one of that people that used to think that economics had everything to do about money, but after studying some behavioral economics and behavioral psychology, I just realized that economics has nothing to do about money, but has everything to do about people. So basically, economics is the science that studies how people interact with each other into a system, and how changing the constraints on people, we can change the systems from one state to the other. And some of the constraints that we can change on the system are love, hate, money, power. So basically, we're talking about people. And software is made by people, for people. Every time we forget that, we don't have an optimal result, and that's Some great examples that we have from these new digital economy companies that are changing the way that people interact with each other are that the largest car transportation company in the world owns no cars, which is Uber. The largest lodging company in the world owns no real estate, which is Airbnb. The largest online retailer in the world owns no stock, which is Alibaba. And the largest content network in the world produces no content, which is Facebook. All of these companies, they have something in common, is that they only exist because of software, and they are changing the way that we interact with other people. So that's all about software. I also like to introduce myself as a software craftsman, and the best definition that I have for this is that a software craftsman or craftswoman is somebody who cares about his or her job, because we know that software can improve the people's lives for the better. And I think that if you're all today here trying to learn better ways to deliver better software into production faster and safely, we all care about our job. So I'm pretty sure that we can have a better future with all the work that we're producing, because we know the experience of being miserable with software that is not up to our expectations. So we can make a choice, and I think we all of us here, we already made it, because we don't want to make people feel miserable. We want them to have a better life with the code that we're producing today. So congratulations to all of you. And when talking about DevOps deployment options, it's all about DevOps. And when we're talking about DevOps, the single most important concept about this DevOps thing is what I call the feedback loop, because think about if in all of the human activities, we need a feedback loop to assess if we're doing the right thing right. And the faster we have this feedback, the better is the result of the thing that we produce. So we do that with many different things, like for coding. Now that we have syntax highlighting and on-the-fly compilation, now we produce better code. Now that we have automated testing, we have a much shorter feedback loop cycle, so we can quickly assess if we didn't break anything else in someone else's code. Now that we have integration testing, continuous integration, we can quickly assess if our code works properly with the code that other people produced, or at least if it's compiling. So we shorten the feedback loop and we improved the software that we are producing. But when we're talking about DevOps, imagine that in each one of the releases of software that we create, we are producing a long list of commits, so we're changing a lot of things at the same time, and if anything goes wrong into production, we have a very hard time trying to figure out which was the piece of code that produced this particular bug in production. But imagine if we could constantly reduce the amount of commits that release into each one of our releases into production until we have like the ideal commit size, batch size of one single commit. So if we can generate one release per commit, then maybe if we have a problem into production we can establish a correlation, if I just changed these 15 lines of code, what caused the bugs that I have now into production? Maybe it was that 15 lines of code. I know I'm oversimplifying the correlation of bugs because we have more variables to take account for. For example, usually the things that change between one release and the other are three different types. You have code, you have data, and you have environment. But just trying to simplify all that, if you can establish that a simple correlation, I just changed that, and this caused this bug. So it's much easier for me to fix the problems. It's much easier for me, and not only for bugs. If I change this piece of code and my sales online have reduced it by 10%, where's the problem? Maybe it can be on that that single commit that I've just released into production. So it's much easier for us to establish a correlation because the feedback loop is much, much shorter. In this case, we have a much better improved feedback loop. So one of the ways that we can try to achieve this better feedback loop is try to automate everything so we can have different types of deployment scenarios into production. And as I said, technically, the term that I've just described to you, reduce the amount of things that you release into each one of your versions, is called a batch size. And DevOps, for many of us, means that DevOps equals to reducing your batch size. If you do that, you will be able to, because people say that DevOps is culture, process, tools, automation, and everything else, but the single goal that we have in DevOps is, if we reduce the batch size, we're also reducing two other very important measures, which is the lead time, the amount of time that you take from idea to production, and cycle time, which is the amount of time that you take between the releases. So if you're reducing batch size, you're also reducing two other important measures because they're all correlated. But even if you try to reduce further your batch size, there will be a specific moment of time that you're not able to reduce your batch size anymore, because we have something called a maintenance window, which means you're not allowed to disrupt users into production, and that's why the ops guy, they ask you to, well, you're only allowed to release a new version of software on a Saturday, 3 a.m., and I want to do that more frequently. I don't want to be Saturday, 3 a.m. Every single week deploying software into production. So we need to break the cycle. We need to be able to reduce our batch size to a smaller amount, which can be smaller and faster than the maintenance window proposed by the ops guy. And for that, we need zero downtime deployments. And for us to achieve zero downtime, we have the single most important requirement for zero downtime deployments is that we need at least a blue-green environment, a blue-green deployment. And for blue-green deployments, how does it work? Traditionally, we have clients issuing requests directly to my deployment, which I'll call the blue one. Then if you want a blue-green deployment architecture, we need to add another component to our architecture, which is called a proxy. It can be a reverse proxy, a load balance, it doesn't matter. I'm just saying that it's getting the request on behalf of something and forwarding that to my blue deployment. Then if I do that, I can have a duplicate copy of my environment with equal capacity. Each one of them is able to handle like 100% of my requests into any given moment, because they will. So if I want to perform a blue-green deployment with zero downtime, then maybe if clients are issuing requests to both deployments at the same time, I can ask the proxy, well, disable the green deployment for a moment, because I want to stop the green servers, copy the new artifacts, start them over. If I'm using a language a platform like Java, maybe you need to issue some dummy requests to warm the server up, and when everything is warm and responding quickly again, then I can ask the proxy to, well, switch, and I'll do the same things again over the blue. So I'll stop the servers, copy, warm up, start, warm up, and then if everything's okay, I can switch the production requests back to the blue deployment. And this blue-green deployment scenario is not only allows you to have zero downtime, it also allows you to have the safest possible option for deploying software into production. Because if anything went wrong to the green deployment, oh, now I'm having a lot of errors into production, you still have the blue version without being updated. So it's safe. So it's a safe thing for you to do, to just update. You switch the router, or you wait for some time. Is it going very well? Well, maybe it's okay. Then I can update the other deployment. And when I do that, if everything is working fine, I can ask the proxy, maybe now I can load balance the request between one environment and the other. This is the simplest possible zero downtime architecture that you can have. You need two environments and a load balancer in front of that to achieve blue-green deployments. And of course, I'm a bit oversimplifying the concept because I'm just talking about code. You also have to deal with state. But I cover that on my book too, so if you want to know how do I handle state when dealing with blue, green, and zero downtime deployments, maybe I can have some solutions for you on the book. We also have another strategy, which is called canary deployments. And how does canary deployments work? Usually, when you have a traditional blue-green deployment, well, I update one version. In this case, I had a green deployment, and I decided to update that. But the problem with traditional blue-green deployment is that when I release a new version, and I ask the router to change the route to the new deployment, I'm handling 100% of my production requests to the new version, and if there's a problem on that new version, 100% of my users will have the same problem at the same time. So maybe it was a nice idea to have what we call a canary deployment, so I can not handle 100% of my requests, but maybe 10% of my requests to that new deployment. So if I have a problem, only 10% of my users will be disrupted. And the analogy that we have in the canary deployments is that a long time ago, I hope, yeah, we have coal miners, and when you have a coal mine, when you're mining there, it's possible that you can find a natural gas, some natural gas, and the problem with natural gas is it doesn't smell. So you might be dying, and you're only aware when it's late. That's why the old miners, they used to carry canaries for two different reasons. First, they sing. So it's good to be under like 200 meters on the ground. With canary, they're singing, and another reason for doing that is that they die very fast. So if you're walking by the mine and suddenly the canary stops singing, you better run because you might be the next one. But now with this modern equipment, IoT, maybe they have proper equipment, so they don't have to carry a canary just for that. You can set up an alarm based on how much oxygen you have available on the mine. But canary, that's the analogy that they use when they're trying to use canary deployments. And so canary, you start small, or maybe you can choose just a specific set of users. Well, maybe I can try first with my internal users instead of update first my customers, because these internal users, they're part of the company, they can't complain much about it. So you can start internally, and then you can start broadening. You can get that very, very, very annoying customers and leave them for the last batch. So canary, you just keep increasing that, and if something wrong happens with your canary, you can just, something's going wrong now. Maybe my new version is too slow that it can't handle 100% of my requests. It can handle only 30% of my requests. Then it's safe for me. I can stop the release and roll back to the previous version because it's still running into my Blue deployment. That's a canary deployment strategy. And now you might be thinking, blue-green deployment, I think I could do that because I could install an HA proxy server, then I could route that manually. But with canaries, now it starts to become much harder. Oh my God, it's too much work for me. To be able to deploy software safely, I have to do a lot of things into my deployment environment and deployment pipelines. And yes, it gives you a lot of work. But fortunately, people that started doing this kind of things, this kind of deployment to production, like 5 or 10 years ago, they need to do that all by hand, and they needed to create the tools and all of these things. But now it's 2017, and most, if not all of these problems for deploying software into production were already solved. Today, we have different types of software being able to do that, for doing that, and just because, I think, for me at least, it's a fact, containers are already dominating the world of how we package, deploy, and consume software. So I think it's a safe bet for us to think that in the very near future, we'll be all using containers to deploy software productions, and we can use container technology to be able to achieve all of these basic scenarios. Now these are considered basic deployment scenarios very easily because they are already automated. And if everything is automated, maybe you can have even more interesting strategies. So I can also show you like rolling upgrades, which is a kind of blue-green deployment with canary updates. But it also has some other interesting features because you're not tied to only have just one blue and green, like 2 deployment environments. You can have many. And how does rolling upgrades work? Imagine, for instance, if I have a cluster orchestrating my containers, maybe I request this application needs at least 3 instances running into production. And if I apply a rolling upgrade, it means that if I say that, you need at least 3 instances responding my request into into any given moment. So I can ask my platform to just update one. If that deployment is running well, then you can kill an old one, and now you have 3. If now I have 2 new old versions, 1 new version, now you can create a new version and wait, is everything okay? Then you can kill one of the other one. Then it just keeps rolling until 100% of your instances are updated to the latest version. And if anything goes wrong into each one of your deploys, maybe that application now is returning a 300 error or a 400 error in the response. Then it automatically rolls back all of the previous versions. They were blue, they roll back everything to blue back again automatically. You don't have to do anything. And in fact, most, if not all of the container orchestration platforms we have today already implement rolling upgrades for free for you. So you don't have to bother anymore. You just have to use a modern container orchestration platform, right? So we'll deal with, before dealing with this part, I want to show you a demo because it's much more interesting to show you something instead of just talking about that. So here, let's do the basics, blue-green deployments. So if I have here, here I show you, I have a Kubernetes cluster running on a machine. On top of that, I'm running OpenShift, which is a set of tools that allow developers to be able to interact more easily with Kubernetes, because Kubernetes can be kind of hard for developers because it was targeted for ops guys. And just in case you don't know, Kubernetes currently is the most popular, probably, orchestration platform in the market. It is a project, an open source project developed jointly by Google and Red Hat. And Kubernetes is based on the same technology that Google uses to run their containers in production. And they run about 2 billion containers into production per week. So we made a bet that maybe if they run 2 billion containers in production per week, if you want to run your 5, 6, maybe it can be safe too, right? Yeah? I don't know how many do you want to. But suppose I created 2 different deployments, a blue and a green one. So if you check a blue, hello from blue. If you check a green, right. Now how do I create a blue-green deployment with Kubernetes and OpenShift? For me, I just have to go here, application, routes. Let's create a dynamic route, and I would say that I want to create a blue-green route, and I want like it will all go to blue. So if I just create the way it is, and I open this URL, 100% of my requests will return blue. But maybe I don't want to do that. I want to keep dynamically switching that. So I could just, let's open my cheat sheet, which I just close it. And if I want to switch that to green, maybe I can just issue a single command which uses the JSON patch specification. So I just changed my route, and if I open the blue-green again, it's green, right? Sorry for the Chrome cache. It happens a lot to me. And you have, now it's green. But okay, this is the basic. If I want to roll it back again, I just have to change the name of the service that I'm routing the things, and now it's blue. So it's very fast, very easy. You don't have to configure a router. You have everything out of the box if you're using a modern platform like Kubernetes and OpenShift. But maybe I want to change that. Maybe I want to try like something. I want to issue a canary deployment, which is, again, what I'm going to show you now. It's what I call a dumb canary deployment, because you're handling that first manually, and secondly, you're handling that through infrastructure, because since infrastructure is on the lower levels, you don't have the application knowledge, the business logic on that. That's why I call that dumb, okay? But it's not a pejorative thing. And if I want to change this route, let's say that I just want to change it, and I want to split the traffic. So I want like 80% of my requests to go to blue, and then maybe I want 20% of my requests to go to green. 20. And I say that. Save. And I won't be able to show that on Chrome, because Chrome, I don't know why. Because by default, OpenShift implements a sticky router, so each one of the clients always goes to the same backend. But I can show you the result if I use the command line for that. So if I do it here, and if my font is big enough, I can do that. You can see that, well, it was supposed to be 80-20, but you know how demos work, right? Did I mistype something? But it's distributing the request, okay? You see, you have to be prepared for weird things to happen. And, well, I just did blue and blue-green deployment. And maybe, you can see now the traffic, yeah, should be split 80-20. I have to check. Oh, I think I don't know. I just forgot to change the behavior to round robin. Yeah, now it's working, okay? If you forget one command, it changes the whole thing. Now you have 80% to 20, and because, yeah, OpenShift has some smarter routing options, so if I want to change to the dumb one, which is round robin, one for each, then I have to change that manually. And if I want to check that, I want to create, add a new deployment. I'll show you now how can I deploy a container image to OpenShift, because I'll use this container image later, and you will know why, because I want to use some smart deployment scenario. So I'll deploy a purple one. So I just have to type the name of the image, which is just deployed that on Docker Hub. So creating, my application is creating. Okay, and you can see that I'm instantiating and everything else, but OpenShift is already complaining because the way that I'm deploying my software is not the safest possible one. Because one thing is for me to know that the container is running. Another thing is for me to know if the application is running correctly. And another thing is my application warmed up already, so it's responding in a certain amount of time? So Kubernetes has, by default, what we call health checks. Has two different kinds of health checks. Has readiness probes and has liveness probes. Liveness probes means that is my container alive? It checks the Docker container to see if the container is running. And if it's an HTTP port, it checks the request, the response code for this path, which I can configure. If it is between 200 and 399, Kubernetes considers it's okay. If that's a TCP port, it just checks if it responds to the connect. So I can add a liveness probe, and readiness probe means that I can check the same path again, but I can wait for an amount of time, but it has to reply in like 5 seconds. If I issue this request and it takes more than 5 seconds to reply, then I consider that it's not alive, it's not okay for me, and Kubernetes automatically detects, oh, this is not performing correctly, it kills and it starts another instance, okay? That's why you should always have more than one instance running to production, because you can have properly these health checks and assure that at least one instance of your application is always responding into production. Okay, so I could do that. 1 second, maybe 1 second is not enough. 5 seconds. So if I do that, it removes the warnings. Okay, I changed the configuration. So Kubernetes is trying to create a new deployment with the new health checks, because if I type it incorrectly parameters, because the application will take more than 5 seconds to respond to that URL, and it will never be considered healthy. So I would be stuck because Kubernetes will keep killing the instances and creating new ones. So every configuration that I change, I trigger a new deployment. Because if anything goes wrong, Kubernetes will roll back to the previous configuration without asking myself, right? So you always have something that is running into production. This was the initial warning. And OK, now it should be working. Now let's go to the other stuff, rolling upgrades. So I have 20 minutes. 20? OK, then I can show. I'll create 20? OK. Then now I'll create a new application. I'll call that deploy master. Oh, I just want a REST web endpoint. So let's generate a project. So you might be wondering, how does rolling upgrades work, and how hard is that to set up my application to be running on Kubernetes and OpenShift? So let's just create here an application. I just want to create resources static. I just want to create a new index.html h1 hello from Malaga. Okay, it's very small, but that's just an HTML. So it should be, if it's working correctly. OK. Hello from Malaga. It's OK. So let's deploy this thing. It used to be very hard to configure applications for Kubernetes, but now, since to some cool stuff like some cool projects like Fabricate, for me to get this project and deploy that to Kubernetes or OpenShift, I just have to get here and run this Maven plugin. And this plugin is smart enough, if you're using Java, it's smart enough for you to check if that's a Java application, if that's just a plain Tomcat application, if that's a Spring Boot application, if that's a Vertex application, if that's a Fat-Jar application. So it automatically detects which classes are you using in your application and performs the better possible setup for you for memory, health checks, and everything else. And if you want to deploy that, you just have to type mvn fabricate common deploy, colon deploy, and it's already building my Docker image. It's already, okay, it's building now. And now it's already built my Docker image. Now it's pushing to my internal Kubernetes registry, and it's deploying. Now it should be running here. So if I get here to my console, I hear my application is already running the deployment. And once it goes alive, it will show. That's a problem of liveness and readiness check. Shouldn't it be working? Come on, I'm not lying. Deploy master. Oh, it's working. Hello from Mac. When did it change? And now, for me, for the rolling upgrades to work properly, I need more than one instance of running. So I'll scale. I don't know how many of you can hear, but well, it's a lot of things to be running in one notebook, so my CPU fan is like making some noise. So if I have 5 pods, because each one of them is a virtual machine running, right? All of them are Java applications, so you can expect some swap to be happening here. So I have 5 instances of that running. So if I change the code of my application, not just hello from Malaga, but hello from Jay on the beach. If I save that, and I ask my application to be deployed again, I'll just clean to make sure it changes. So now Fabricate is triggering another deployment in Kubernetes and OpenShift. It's just building. Okay, jars. It's building my image inside Kubernetes. And okay, now let's switch here because sometimes it's so fast. Oh, it's already triggered a build, so it's building a new version. And when it ends, it already started. It started a rolling upgrade. So you can see now you have 5 versions. Now you have 2 of the new versions. Usually it's too fast, so the interface usually gets a bit delay. But if I said that I want at least 5 instances of my application running in production, Kubernetes guarantees that I will always have at least 5 instances running, because the first instantiates one. If it's running properly, it kills one of the older versions, and so on. So that should always have 5. But now it's down to 1, because I didn't change the configuration inside my Maven file. Okay, but I'll get that to later. Okay, and what else do I want to show you? That's basically blue-green canaries. You have canaries for free if you use like the rolling upgrades. Rolling upgrades, but as I said, that's just dumb. That's the most that you can get only by using infrastructure. Now we have to do we can do something more smart. And by smart, I mean we can use like A/B testing. And if you think about all of the deployment strategies that I just showed you until now, which just meant that I have an old version and I'm deploying a new version. It's just a matter of replacing an old version to a new version. But when I'm talking about A/B testing, I'm not talking just about releasing a new version in production. I'm talking about testing hypotheses. I don't know which version will be more successful. Maybe if I tweak a bit my recommendation engine, I'll be able to sell more. Maybe if I change how the steps of the workflow of my application, I'll be able to allow users to perform more things in a lesser amount of time. So we're talking about business hypotheses and not just releasing new versions into production. It means that we'll need these 2 different pieces of software running into production at the same time, because we'll need to assess which one performs better into production. So A/B testing, which means A/B mean I have 2 different business hypotheses and I want to know which one performs better. You have 2 different ways to achieve A/B testing in production, but both requires that you have advanced monitoring, which means monitoring for you, for the ops people, and for you developers doesn't mean anymore just, is my service live? Monitoring now means which business metrics I'm monitoring, because I need to know which version or which deployment will perform better, which business hypothesis will perform better. To achieve that, we can use what we call a smart router. which is like a traditional router, but now we have application, we have layer 7 business logic, so we can route like, I just want to route the internal customers first, or I just want to route the people from Spain and the rest of the world, because I think Spanish people think different, and maybe I want to test these hypotheses on them. Or maybe I'm having a bug just on the iOS users, and I want to create a new, and if I just create a traditional canary or something else, well, the iOS users will keep having the bugs, and I'll have to, like 1,000 of lines of logs. Not all of them are useful for me to try to detect the bug. So maybe I can create a specific deployment trying to fix that specific bug for iOS users, and I can ask the Smart Router, Smart Router, I just want the iOS users from Malaga to go to that deployment so I can debug what's happening on that deployment. That's one strategy that is possible with smart routers. Another thing that is possible, another possible solution for A/B testing is for me to use feature toggles. Feature toggles is just like, I know some people laugh at feature toggles, but it means that now I have a distributed if-else framework, which means that I have another state to be managing, which I just turn on and turn off some variables on my system, and it switches which code is going to run. Well, I know it sounds very silly, but you have, like any kind of architecture, you have pros and cons for smart routers, and you have pros and cons for feature toggles. I'm going to discuss all of that, but first I'm going to show you. So how can I handle our smart router? I have here, let's go to my Zoo, and I want to run. So I'm going to run my Zoo instance here. Oh, I have to stop the other application. Yeah. This one I'm going to close because I won't use this anymore. So I'm going to start a Zoo gateway here. Okay, now it's running. And if I get you the code, let's presentation mode. Zoo is part of the Netflix OSS stack. So basically, if you get the source code for Zoo, it's ridiculously simple. You might be wondering, whoa, why didn't anybody invent this before? Well, usually the most obvious things are also the hardest one, but the Zoo source code is very simple. Basically, it's a filter, a servlet filter, which uses a loader, and this loader by default is a Groovy loader. So it looks for Groovy classes on a specific folder, and every five seconds by default, it is rereading the configurations. If anything changes at all, it changes the routing definitions. And it works especially good for Netflix because Netflix internally uses a Cassandra distributed file system, so they can just get the files and they're spread across their network using Cassandra. So if I want to change a route, basically I just created now a Zoo router, and I'm saying that I created a round-robin router, and I'm saying that I want 50% of the requests to go to the blue deployments, and the other 50 to go to the green. That's very basic stuff, and what can I do with that? So if I get here and go to my 8080, and the problem with Chrome is that always caches my request. I have to go to inspector mode, so now it loads properly. So blue, and if I reload here, green, blue, so 50-50. And the cool thing is that I can just go here. I used to do that with live coding, but I figure out that I usually get lost on the curly braces. So now I added some logic saying that, oh, if that's an iPhone user, I don't want to route the guy to the blue and green. I want you to route that to a new deployment, the purple deployment that I created before. So if that's an iOS, we're going to the blue-green or to the purple or else. So first I'll try with the Galaxy S5. And this one doesn't explode, by the way. Blue, green. But if I change to the iPhone, it doesn't work because it's not responding. Where is the purple? Oh yes, because I didn't expose the things. The cool thing about Kubernetes, when you deploy a new application to your environment, it's just available internally. If you want to expose for that, you have to explicitly expose. So I didn't create the endpoint. So now that I do, okay, now I have a purple endpoint. Now I can just reload, and it's purple. Okay, so you have some smart routing, and since you're doing just Groovy code, which is Java compatible, you have all of the access to the business logic. You can check which is the user that is logged in, then I'm going to route him to that specific deployment. So that's how you do that with using smart routers. But how can I achieve the same kind of thing using feature toggles? So let's switch to the other demo, running feature toggles. So now I want to open this one. So let's exit presentation mode and switch to the other one. So basically, if I want to use FF4J, which I consider, at least for now, to be the most mature feature toggle framework for Java projects, the dependencies that I have to add are just FF4J and F4J web, because I'm using feature toggles for a web application, and I want the web console. It doesn't need to be embedded on application. I'm just using that because I didn't want to run two simultaneous artifacts in a network. So it's the simplest possible scenario. So, and if I do that, I'm gonna controller. I just created a recommendation controller, which uses my recommendation engine to give me some recommendations. So if I get to run this, I'm running my application. So if I access localhost recommendations, it's gonna give me some recommendations for some not that good food. But if maybe I want to try with my feature toggles. If I switch my recommendations to another recommendation engine, it will perform better into production. And how do I do that with feature toggles? Then I just enable the FF4J console for that. No, it's very big. Which just shows me some feature toggles. I created a hello feature toggle, and I created a new recommendation engine feature toggle, which is on by default. But if I get back to my source code, and I decide I'll just type it as a new improved recommendation engine. So I'm just going to change my code here. Improved recommendation engine. And I know I'm using field injection, but well, that's, for now, it's the easiest way to do. And I inject the FF4J, because if I get my application, I just instantiated my FF4J using this XML, which is pretty simple. And I instantiated my recommendation engines, just in case you want to check my XML. It just has saying which feature toggles I have, if that's enabled by default. I'll say false, and I can have some description. And if I go back to my recommendation controller, I can say that if ff4j.check new recommendation engine return improve the recommendation, get recommendations, else right? No. Missing parentheses. Right? Should work, right? Okay. So if the feature toggle is on, I can show the improved ones, or else get to the default. So I'm going to rerun that. And you see, it's showing me hamburger, hot dog, and cola. And if I get to my console here, I just turn it on. Now it's on. If I get back here, oh, it's much better food, isn't it? Yeah? I think so. So you can dynamically change this if you guys get to the console. Oh, come on. Here. And if I turn it off, which is kind of distributed if. Some considerations about that. back. Which one should I choose? Well, I think it really depends on your software deployment pipeline. And one of the things that I've learned in my 20 plus years of experience developing software is that when we were younger, we used to be much more dogmatic. Well, this is the right way to be doing things. And then when you get older, you realize that it's much more a thing of it always depends. So you should be very pragmatic on the things that you choose. So depending on how you have modeled your software deployment pipeline, you have one of the options will be better than the other ones. But of course, you can't be thinking truly about A/B testing if you didn't solve already the problem of deploying software into production. Because then you need advanced monitoring based on business metrics. Then you can think about A/B testing. The problem and the advantages of smart routing is that with smart routing, you always need two different kinds of deployments, which also means that these kind of deployments are usually tied to two different feature branches available in your source code repository. And the bad things about feature branches in your source code repository is that people tend to make these feature branches live long enough for them to test their new feature and to deploy. And imagine, didn't I say that DevOps is all about reducing our batch size? When you create a branch and you start to commit on that feature branch, when you merge that feature branch into your master, what does it mean? You had this 50 commit size, batch size. You're just merging them all of the once. Yeah, you just defeated the purpose of trying to reduce your batch size, and that's one of the bad things. So if you're trying to use feature branches to create different kinds of deployments, you should make them as small as possible. Maybe they should be at most like 1 or 2 commits to get a small batch size in either case. And the feature toggles, the problem is that, well, I've just shown you the simplest possible way to create a feature toggle, which is to use an if. But they have very tight integration with, for example, with Spring. So you can conditionally check which bean is injected depending on how your feature toggle is working. Or you can also use some aspect-oriented programming to change which piece of code is running between each one of your toggles. And the problem with that approach is that now you have to maintain 2 different codes in your application. You have your hypothesis A code running here, and your hypothesis B running code here. And since you're just using annotations or if statements to handle that, it's very easy for you to forget that in production because, remember, it's used to test business hypothesis. Once you figure out which one is the best, you should be removing. But it's very easy for you to it's already working, why should I care to remove that? And that's one of the things that happen. And one of the biggest problems that I see in this approach is that, okay, the good thing is we're always committing to the master branch of my code repository. So technically, I still have a small batch size. But the problem with feature toggle is that, remember that I said that usually we have 3 variables that have consequences to productions when you change. What do you change? You change code, you change environment, and you change data. If you have feature toggles, that's another variable that you have to take into account, because now you have if you get the feature toggles, we could put that on the environment or data side, because now if anything goes wrong in production, you have to check in 4 different areas. You have to check your code, your environment, your data, and your feature toggle states. Which was the exact feature toggle state that I had when this thing happened? It might get very hard to start to reproduce things because it's very hard. It's another kind of state for you to manage. So if you want to use feature toggles, I recommend that just as feature branches, you should have a small amount of feature toggles into production. You should get rid of them as soon as you can. And that's it, because it also has its consequence. So there's no clear winner. It's all a matter of trade-offs. And okay, I showed the demo before. And that's what I wanted to show you today. I know it was a very quick and brief introduction between many different things. And I'm working on, now it will be a more advanced presentation just about A/B testing, but then I'll be digging about the deep things about each one of these strategies. But I hope you all have enjoyed it. I'll also be publishing some articles about the subjects on developers.redhat.com. And of course, if you follow me, I'll be sharing these news as soon as I get them. So thank you very much for being here. And I don't know if we had time for questions.
Yep, we've got 5 or so minutes for some questions, so to the floor.
Oh, I have one special request before we leave. Can I take a selfie with you? I like that as a souvenir. So, hey! Thank you very much.